Hi everyone, this is Shivkrishna, Chemistry Faculty of Narayana Group. Students, today I am going to discuss the question paper which was held on 27th January 2024, Shift 1. Student, of course, these questions are extracted from student memory based. So, any misconception or ambiguity in the framing of question, it will be clear later. So, let us see one by one. Yes, student, the first question, which of the following has the highest enol content? This can be solved easily. In the given option, the first is the correct one. Since you see students, after enolization of the first option gets more stable compound. Therefore, according to the given question, option 1 is the correct option for the answer. Now, go for the next question, student. Which of the following is the most acidic? Generally, here the options are phenol and alcohol. Phenols are more acidic than alcohol. So, the first option is not possible. Among the 2 and 3 4, the more withdrawing group will stabilize the conjugative base more. Therefore, better option is the option 4, because in the option 4, that is 2,4 dinitrophenol. 2,4 dinitrophenol has 2 withdrawing group at ortho and para position, which can stabilize the conjugative base easily. Therefore, the most acidic among the given option is 4 is the correct answer, student. Now let us go for the next question. Which of the following cannot show variable oxidation state? Students, if you see, options are fluorine, chlorine, bromine, iodine. Variable oxidation state. Fluorine has no d orbital. Due to that, there is no chance to exit the electron. Therefore, fluorine is the correct option for the given question. Now, let us go for the next question, student. Fourth one. IUPAC name. Yes, the given question is a student. That is 1, 2, 3. Since there is no functional group in the given molecule, according to the lowest sum rule, that is 1, 2, 3, ethyl group gets the third position and the methyl gets the first position. Therefore, the answer should be 3 ethyl 1 dimethyl cyclohexane. Therefore, option 2 is the perfect answer for the given question, students. Now, let us go for the next question. Yes, the given compound is, yes student, let us see, the given one is a cyclic compound. Therefore, the answer 4 does not suitable to it, because it is not a cyclic one, because it is a cyclic one. And you go for the next second and fourth option, that is aromatic and anti-aromatic. The compound is not aromatic as well as not anti-aromatic, since complete conjugation 4n plus 2 pi electron is not there. Complete conjugation and 4n pi electron also not there. Therefore, the compound is not aromatic and anti-aromatic. Therefore, for the given question, the correct answer is alicyclic 1 is the correct one, students. Now, let us go for the next question. Sixth, which of the following is polar molecule? This polar molecule means we have to select dipole momentum. You see, for the symmetric molecule, the dipole momentum is 0. So, ethane is symmetric, the dipole momentum is 0. As well as carbon tetrachloride is also a symmetric molecule, the dipole momentum is 0. And CH4 also symmetric with respect to tetrahedron. All of them are symmetrical 1, 3, 4 except the second option, chloroform. Here all the dipoles are in same side and the dipole momentum also not equal to 0. Therefore, the correct option for the polar molecule is option 2. Now, let us go for the next question, students. Seventh one. In which of the following compound the central atom has or exhibit +4 oxidation state? See question option 1. SO3 -2 -2 -2, therefore sulfur is +6 in option 1. Go for the second option, H2SO3. Yes, student, OH is -1, OH is -1, oxygen -2, then the sulfur become +4. Or otherwise we can do another way also. Let us see, 2 into hydrogen charge plus 1 into sulfur charge, and what is that, 3 into oxygen charge. The overall value is become 0. 2 into +1 plus sulfur plus 3 into -2 is equal to 0, and the overall value become equal to +4. Therefore, the +4 oxidation state on the central atom present only in H2SO3. Directly we got the option. Next, you go for the next question, student. 8th, in the given that it is the given that radius of third stationary orbit is r, find out the radius of the fourth stationary orbit. Already you know, Rn is directly proportional to n square by z, where n is the orbit number, z is the atomic number, r is the radius of the orbit. Now R3, since it is asking you third stationary orbit, and he was not mentioned any atom, so we can take it as a hydrogen. R3 is equal to k into n square, third stationary orbit 3 square by 1. Therefore, k is equal to R3 by 9. Find out the radius of the fourth stationary orbit. R4 is equal to some k into, that is 4 square by 1. That implies R4 is equal to R by 9, because R3 mentioned as R, into 4 square mean 16. Therefore, the fourth stationary orbit radius become equal to 16 by 9 R. The given option is suitable to the option 1. So therefore, the correct answer for the given 8th question is option 1. Now let us go for the next question, student. 9th, select the strongest Brownsted base. According to Brownsted-Lowry theory, H plus donor is the acid, H plus acceptor is the base. To take H plus, it should be lone pair donor. Therefore, the best lone pair donor, indirect question, that is best what is that? Best lone pair donor. So among the given options, in the fourth option, the lone pair become free, since there is no conjugation with respect to the lone pair. But in the option 1, in option 2 and option 3, that is diphenylamine, aniline and azole, in all of them the nitrogen lone pair is in conjugation with the given what species. Therefore, option 1, 2, 3 are not possible for the best Brownsted base. Who is that? Fourth is the correct answer, because of lack of conjugation. Go for the question 10. The electron configuration of neodymium is, it is easy to answer the question based on the memory. That is option 1 is the correct answer. 4f4 and 6s2 is the electron configuration of neodymium. And simple question and easy question, I think so. And question number 11. Ethanol shows turbidity with Lucas reagent, that is concentrated HCl and anhydride ZnCl2. Shows turbidity with Lucas reagent. Ethanol is a primary alcohol, students. Therefore, tertiary alcohol produces turbidity immediately. Secondary alcohol will produce turbidity after few minutes, but primary alcohol gives turbidity after heating only. So answer upon heating is the correct option for the given question, since ethanol is a primary alcohol. Next question, student, 12th. Which type of linkage is present in nucleotide between base and sugar? I think most of the student gets ambiguity in this question, since You are thinking that it is the linkage between two nucleotides. No, student, the question is not the linkage between two nucleotides. It is the linkage between the base and sugar, like this. Sugar and base. It may be purine base or may be pyrimidine base. Purine base or pyrimidine base. Here the linkage between the sugar and the base is not peptide linkage. It is not the glycosidic linkage. Glycosidic linkage generally present between two monosaccharides or carbohydrate units. Here the linkage should be unglycosidic linkage. Students are thinking the question is what is that phosphodiester, since you are thinking that is a linkage between two nucleotide units, but that is not the question. Here the question is the linkage between the base and sugar. It is a unglycosidic linkage. Now let us go for the next question, student. The complex which has maximum spin angular moment. Spin angular moment, directly we can calculate based on number of unpaired electron, that is under root of n into n plus 2 Bohr magneton, where n is the number of unpaired electrons which has maximum number of unpaired electron that has maximum spin angular momentum. Let us go for the complex one. Fe F6 minus 3. Here iron as plus 3 oxidation state, 3d6 4s2. Then you can write that as a 3d5 4s0. That means F minus is a weak field ligand. Weak field ligand. Therefore, all the 5 unpaired electrons are only present. Therefore, n is equal to 5 here. If you go for the second option, FeCN taken 6 minus 3. Here cyanide is the strong field ligand. Again iron the charge is a plus 3. Strong field ligand and the configuration become 3d5 only. But because the strong field, the electrons gets paired up. Therefore, only one unpaired electron is present. If you go for iron H2O taken 6 plus 2, that is hexa aqua iron plus 2. Then here also in the option 1, in the option 2, in the option 3, iron again here is plus 2, that is 3d6. The students are getting a wrong option is here 3, since 6 electron is there, but the water is a weak field ligand. While filling the electrons according to Bohr rule only, for what is a Pauli's exclusive principle only, Hans principle only, so electron does not get paired up. Then d6 configuration, the electrons are still 4 only. Here is the problem. According to Hans principle only we are pairing, not opposite to it, since water is a weak field ligand, the electrons are 4 only. And if you go for the option 4, vanadium plus 2, okay, scandium, titanium and vanadium, that is plus 2, d3 configuration and 4s0, 3d3 4s0. Therefore 3 unpaired electron, since water is a weak field ligand where n is equal to 3. So among the given option which has maximum number of unpaired electron in the given complexes with central atom is first one, FeF6 minus 3. It has the 5 unpaired electron. Therefore answer should be 1. Now let us go for the next question, student. Question number 14. Calculate the temperature at which kinetic energy of monoatomic gaseous molecule is equal to monoatomic gaseous molecule kinetic energy. The average kinetic energy is equal to 3 by 2 kT. Actually, this comes under gaseous state lesson. According to the NTA prescribed syllabus, the question should be out of syllabus, but we don't know the question may be appear or not, but we have to do that. Kinetic energy they given as 0.414 electron volt. You have to come, what is that change into, what is that 1.602 into 10 power minus 19 coulombs, and 3 by 2, and K, that is called Boltzmann constant for molecule, that is R 8.314 by Avogadro number 6.023 into 10 to the power of 23, since K is equal to R by N and the temperature T. After solving, you will get the temperature value nearly 3198.7 kelvins. Therefore, the answer should be 3199 is matching option for the given question. So, this is the question from states of matter. Now, let us go for the next question, student. 15th one, a solution of two volatile components showing a negative deviation from the Raoult's law. Negative deviation from the Raoult's law means AB interactions are greater than AA and BB interaction, where A and B are the two liquid components. After mixing, the intermolecular forces are greater than before mixing, then automatically the P total pressure is lesser than AA and BB. Since before mixing, the vapor pressure, before mixing the interactions are weaker than after mixing. Therefore, the P total is lesser than PA plus PB. Therefore, the vapor pressure after mixing, because of interaction increasing, the vapor pressure decreases and the boiling point is increases. Since after mixing intermolecular forces are greater than before mixing, as the intermolecular force is inversely proportional to vapor pressure. Since as the intermolecular force increasing, the energy required to vaporize will be required more, and the vapor pressure and the boiling point are inversely proportional. Since higher vapor pressure, lower boiling point. Therefore, as the intermolecular force after mixing increases, therefore vapor pressure decreases and the boiling point is increases. For the given option, 1 is the correct one for the question. 16th, during SN1 reaction, which of the following statement is correct? Inversion occurs, retention occurs, almost racemization, 100% racemization. There is a clear answer for this question, student. Generally, SN1 reaction. In SN1 reaction, step 1, carbocation generation. Step 2 is the attack of the nucleophile. Actually, the carbocation is a trigonal planar and there is a equal probability to attack of the nucleophile. But if the carbocation is not enough stable, always it forms a enantiomer ion pair with the leaving group. Therefore, after cleavage of the leaving group also, the leaving group is paired with the carbocation and forms a enantiomer ion pair, which will repel the nucleophile from the front side attack somewhat less when compared to the back side attack. Therefore, there is a little bit inversion of configuration rather than the retention because of the formation of this enantiomer ion pair. Since all the carbocations are not enough stable, therefore, even in SN1 reaction, carbocation as intermediate, there is a little bit inversion configuration is greater than retention of configuration. Therefore, there is a 100% racemization is not possible in all SN1 reaction. Almost racemization is possible. That is the reason why we are saying almost racemization but not 100% racemization. Next, go for the next question. Assertion. Boron is hard element. Yes. Boron has unusually high melting point. Yes. Because boron has strong, crystal lattice. A strong crystal lattice having the B12 units having icosahedron structure. Because of this reason, boron is harder element is a correct one. Boron has usually high melting point is also correct one. But because of having high melting point, it is harder is not the correct explanation, student. Therefore, assertion is correct, reason is also correct, but reason does not explain A, since the high melting point is due to having strong crystal lattice. but because of having high melting point, it is not harder. Therefore, the given both statements are correct, that is assertion and reason, but reason is not the correct explanation to the assertion. So let us go for the next question, student. PbCrO4 when treated with excess sodium hydroxide forms a complex. In the complex, they asked about the complex. Yes, when the PbCrO4 lead chromate when dissolved in excess sodium hydroxide, which forms Na2CrO4 plus a dianionic complex PbOH taken 4 like this, because this complex has like this structure, that is 2Na plus lead tetrahydroxide, that is -2. Therefore, the charge on the complex is -2 and the coordination number of the complex is 4. So, dianionic with coordination number 4 is the correct answer for the given question, students. Let us go for the next. Which of the following configuration has strongest metallic bond? Generally, metallic bond strength, metallic nature, metallic bond strength difference. Metallic nature, the tendency to lose the electron. Metallic bond strength directly proportional to number of valency electrons. Number of valency electron. In the option 2, you see maximum number of unpaired valency electron or unpaired electron. Valency, number of valency unpaired electron. Here maximum number of unpaired electron, because the d orbital also participated, d electron also participated in the d black metals for their metallic bond. That is the reason why more the number of unpaired d electron, more is the metallic bond strength. So according to the given that option 2 has 6 electrons, unpaired electron, therefore the strongest metallic bond is possible in the option 2. Go for the next. All S black elements are found in nature is the assertion. 4f and 5f series are kept below the periodic table is the reason. Actually, these two are unrelated statements. You can know easily, because all S black elements, that is first A and second A, that is lithium, sodium, potassium, rubidium, cesium, beryllium, magnesium, calcium, strontium, barium and radium, all S black elements are found in nature. Yes, all the S black element, their occurrence somewhat occurred in the atmosphere or earth crust. That is the reason why are occurred in the nature. That is the reason why the statement we can say correct. I think so. The question may be asked in another way, because they are completely based on memory based. We cannot justify this is the absolute question. So we can think that as a S black elements are occurred in the nature in free state, maybe the question. But here given that all S black elements are found in the nature. Yes, most of the all S black elements occurred in the nature. 4f and 5f series are kept below the periodic table. Yes, 4f and 5f. 4f belongs to 6th period third group as well as, and 5f series belongs to 7th period and the third group. So to do not disturb the symmetry of the periodic table, we removed there and placed under the periodic table. That is the correct one. So the assertion and the reason are correct, but reason is not the correct explanation for the assertion, since there is no interrelation between the two given statements. And now go for the next question, student. Find out the sum of bond order of CO and NO plus. CO, the number of electrons are 6 plus 8, 14 electrons. NO, nitrogen 7 plus oxygen 8, 15, but he said NO plus, that is The total are 7 plus 8 minus 1, again that is 14 electron. Both are 14 electrons. The 14 electron bond order is already we know, that is 3. Bonding orbital electron minus anti-bonding electron by 2. That is, the bond order is 3 for each. So 3 plus 3, the total sum becomes 6. That is the correct option for the given question number 21. Go for the next question, student. Calculate the mass of methane consumed for the formation of 20 grams of CO2. The question related to the stoichiometric equation, that is methane. He also given that balanced chemical equation also gives rise carbon dioxide plus of water. Actually, 1 mole of methane produces 1 mole of carbon dioxide. 1 mole of methane produces 1 mole of carbon dioxide. That is 16 grams is the 1 mole of methane can produce 44 grams of carbon dioxide, but the given 22 grams of carbon dioxide only was formed. Remains how much methane is consumed. So therefore 22 into 16 by 44, that is 8 grams. Therefore 8 grams of 8 grams, he given in the answer also in grams. So 8 grams of methane is required to combust. What is that? To come after combustion to get 22 grams of CO2. Now let us go for the next question. Find out the number of stereoisomers obtained when 3-methyl-hex-2-ene reacts with HBr in the presence of peroxide. Let us see, student. 1, 2, 3, 4, 5, 6. That is 2-ene and that is 3-methyl. That is 3-methyl-hex-2-ene. 1, 2, 3, 4, 5, 6. Therefore, addition of HBr in the presence of peroxide, it is also called Karash effect, is also anti-Markovnikov addition. It is a radical mechanism. Therefore, the negative part of the reagent adds at less substituted double bonded carbon. Hydrogen adds at more substituted double bonded carbon. Therefore, the answer to be 2-bromo 3-methyl hexane. It has 2 chiral centers. Therefore, the number of chiral centers are 2. The possible number of stereoisomers may be 4. That is RR, SS, RS and SR. These are the 4 stereoisomers are possible for the product formed in the major. Now let us go for the next question. 24. Among the following number of meta-directing groups, that is directive influence of the benzene, electrophilic substitution. Cyanide is a -M and -I group. Therefore, it is a meta-directing group. NO2 is a -M and -I meta-directing group. That is meta-directing group, meta-directing group. COOH is also -I and -M group, is a meta-directing group. Methyl is a +I, and due to hyperconjugation, it acts as a +M like. Therefore, all electron donating groups act as a orthoparadirectors. SO3H is also -I and -M. Therefore, it acts as a meta-directing group. NH3 plus, it acts as a -I group only. Every -I group or electron withdrawing group is a meta-directing group, except halogen family. Here halogen is a ring deactivating, but orthoparadirector. It is -I and +M. Therefore, in the given options, except CH3 and halogen fluorine, all the given are meta-directing groups: cyanide, NO2, COOH, SO3H and H3+. These are the meta-directors, and the CH3 and F are orthoparadirectors. Now let us go for the next question. Before that, the answer of the given question is 5. Yes, 25th. We are given the following information about the concentration of the reactant with initial rates. Find out the reaction with respect to the reactant. We can see the students rate of the reaction. I can write as K into concentration power, let us say as X. You see the first rate when they given 3 into 10 power minus 3 is equal to some K into 0.02 power of X, and then when the rate become 7.5 into 10 power minus 4 at K into 0.05 into power X, I am writing. This is the rate law I have expressed first. When you divide the both equation 1 by 2, then what happened? That is, I am writing that as 30 into 10 power minus 4 by 7.5 into 10 to the power of minus 4 is equal to, that is, I can write that as a 20 into 10 to the power of minus 3 by, that is, 5 into 10 to the power of minus 3 whole power of X. That is 7.5 4 times will go and 5 4s are will go, then that is 4 is equal to 4 power X. Therefore, the order of the reaction should be X equal to 1, that is first order. We can easily solve the question when the concentrations and the rates are given. In this is the better way to get the answer. Now let us go for the next question, student. 26. How many of the following are aromatic compounds? You know those which follow Haeckel rule, that is cyclic, planar, complete conjugative, 4n plus 2 pi electron, 4n plus 2 pi electron, that is n equal to 0, 1, 2 up to so on. That is 2 pi electron, 4 pi electron, 2 pi electron, 6 pi electron, etc. Therefore, those which follow this are aromatic. Yes, according to that, this is aromatic. Yes, this is aromatic. The rules are satisfied here. Yes, individually both rings are aromatic. Here also this is aromatic, and the total this also be aromatic. And here you see this as 8 pi electrons are in conjugation, because minus negative charge is also, when they are in conjugated with the double bond, you consider that as a pi electron. So the total number of pi electron in the given last species is 8 pi electron, that is 4n pi electron. It does not satisfy the aromatic rule, it is anti-aromatic. Therefore, the options only satisfied by 5. Therefore, the answer is 5 for the given question. Next, go for the next question, student. 27. Calculate the number of electron for n equal to 4 and s equal to plus of. It is belongs to atomic structure. N equal to 4. When it is n equal to 4 mean 4th orbit. The possible L values are 0 to n minus 1. That is 0, 1, 2, 3. Since L value depends upon n, L equal to 0 mean 4s orbital, L equal to 1 mean 4p subshell, L equal to 2 mean 4d subshell, L equal to 3 mean 4f subshell. The S can accommodate maximum of 2 electrons, P can accommodate maximum electrons are 2, 6, 10 and 14. But in the given option only is asking S equal to plus of. That means clockwise spin, that is 1, that is 3, that is 5, that is 7. That is half of the each subshell has S equal to plus of. Therefore, the total number of electron can be accommodated is 16 for the given n equal to 4 with S equal to plus of. Therefore, the answer should be 16, students. Yes, thank you very much, student. These are the questions have appeared in the 27th January 2024 shift 1 examination. Thank you very much, students.